Hey everyone. Alright, so here we are today and we're going to try to solve a LeetCode hard problem, which is the largest rectangle in histogram. And we'll start with developing an intuition for the solution of the problem, and then we'll try to write the code and let's see if we can solve it. Okay, given an array of integer heights representing the histogram's bar height, where the width of each bar is 1, return the area of the largest rectangle in the histogram. We have a histogram with certain bars and we are given the height of the bars and we have to find the area of the largest rectangle. Okay, seems easy enough. Let's try to understand the problem with an example. Let's say our heights are 2, 1, 5, 6, 2, and 3. We'll draw the histogram. The diagram is not up to scale. We're just trying to get an idea about what the problem looks like. And now we'll try to look at some of the rectangles which are in this histogram. So one example is this. What's the height of this rectangle? It's going to be 2. And the width is 1, 2, 3, and 4. So the area is 4 into 2 equals 8. Let's put a pin in this. Let's look for other rectangles. And the rectangle, this small one here. What's the width? 1, 2, 3, 4, 5, 6. Okay. And the height is going to be 1. Area is 6 times 1, 6. Okay, let's see if there are any larger rectangles in here. Which is, as you can see on the left side, this one. The height is 5 and the width is 2. Here is 5 times 2 is 10, which is the largest one. Okay, so some of our largest bars were able to give our largest area. Now let's see another example, just so that we can properly understand the question. Let's say our heights array was this one. Okay, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 elements here. Let's try to draw this. We have these 4 ones here, and then we have a 2, and then we have a 4, 5, and another 1. Okay, again you can see there are many rectangles here. This is 1, for example. Width is 4, height is 2, area is 4 times 2, which is 8. Okay, look at another one. This one seems big enough, right? Just like the previous one. Height is 4, width is 2, area is again 4 times 2, which is 8. But it's the same one as before. Are there any other rectangles? Well, what about this one? This one at the bottom here, the small, long. What's the width? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9, and height is 1. 9 times 1. So in fact, it might not always be the largest bar or the largest height which gives you the largest area. Sometimes it can be the small ones down here. Okay, now this understanding will prevent you from going in the wrong direction while solving this problem. Okay, now that that is out of the way, we're going to try to make two statements about this problem. And those statements are going to help us solve this problem, or at least develop a general pseudocode. What are those two statements? Well, before making those, I'm going to draw another histogram here so that we can visualize the statements as we see them. Let's say this is our histogram that we are trying to solve. Okay. So, what are we going to say? The first statement says that our rectangle, which is the largest rectangle, will have histogram bars as its boundaries. What that means? It simply means that let's take this rectangle in here. This is also part of the histogram, right? But its boundaries are away from the boundaries of the nearest histogram bar. In this case, we can always draw a larger rectangle with the same height, but we can extend the width. And since this rectangle is larger than the previous one, we only need to consider this one. Since our goal is ultimately to find the largest rectangle, we do not need to bother with every small rectangle. Okay, let's go to the second statement. The second statement says that our rectangle, which is again going to be the largest, will have height equal to one of the bars of histogram. And why is that? Let's look at the same example. We had this rectangle and we said that we found a very large one. But again, we can extend even this one to match the boundary of the smallest histogram bar under which this rectangle lies. So this new rectangle is in fact our largest possible rectangle under this height. And again, since we are only concerning ourselves with the largest rectangles, so we can again ignore the smaller yellow one and only concern ourselves with the orange larger one. And it is this second statement which allows us to proceed in the direction of a solution. If the height of the largest rectangle, which is our rectangle, will be equal to one of the bars of the histogram, then all we have to do is find the area corresponding to each of the bars, and then the largest of those will be our answer. Okay, what do I mean by that? So let's go back to a previous example to look at this. Let's say our heights were 2, 1, 5, 6, 2, and 3. Okay, let's say I find the area corresponding to each one of these. Let's call this A1, okay, A2, and up to this. I find something AN. Then the largest of this or max of this will be our solution or our result. Okay. Does that sound familiar? Now, how can we find the area corresponding to each one of these? Well, that should be fairly simple, right? I mean, you can just brute force the solution. For each one of these heights, let's draw a histogram again to understand this better. Height 2, then height 1, height 6, under 2, and 3. If we are looking for a brute force solution, then let's say we want to find the area corresponding to this 6 height. All we have to do is go towards left and find an element which is smaller than 6. That will serve as the left boundary, which is this 5. Right? So this is the left boundary, this is the right boundary, same for the right. And then our area will be just this 6 times the distance between the left and right boundaries, which is 1, 6, which is the correct answer. But we are not looking for a brute force solution. Instead, we are looking for a more optimal solution. So let's see what we can do towards that. Okay. Let's go through these elements one by one. And we'll have this storage here for storing those elements for which we cannot just now find the area. So let's start with 2. Okay, let's write down 2 here. For this 2, what's the left boundary? The left boundary is this origin. So we know the left boundary for this 2. but we do not know the right boundary yet because we have not seen the right side, right? So we do not know the right boundary, and as such we cannot find the area. So let's just store 2 here. Okay, now next we go for 1. Okay, let's write down 1 here. 1 is less than 2 if you're looking at the previous element. Therefore, we can confidently say that we have found the right boundary of the rectangle with height 2, which is this one, right? So what will be the area of this rectangle? We can just take the 2 out. Height will be 2 and width will be 1 minus 0 equals to 2. Let's write this here. Okay. And we can remove this now. We don't need this anymore. We have found the corresponding area or rectangle. And we can write 1 here. Okay. Because our list is now empty. Okay. Now let's move on to the next one. 5. Okay. Let's see. We have 5 here. 5 is greater than 1, which was the previous element. Which means we have found the left boundary of the rectangle with height 5, which is this 1. Okay. But we do not know the right boundary yet. At the same time, we have not yet found the right boundary of the rectangle with height 1 because it extends towards this 5, right? We do not know the right boundary yet. So we'll just do this. We'll just add 5 here. Okay. And the element towards the left of this 5 is actually the left boundary of the rectangle with height 5. Now let's go to 6. Okay. 6 is again greater than 5, which is the last element. Same case, we just add 6 here. Okay. Now notice something here. 1 is the left boundary of the rectangle with height 5. 5 is the left boundary of the rectangle with height 6. As long as we can find the right boundaries to corresponding rectangles, we can find all the areas. Let's go to the next element. We see 2. 2 is less than 6, right? It's the last element. That means that we have found the right boundary of the rectangle with height 6. What's the right boundary? This 2, which we just got. Okay, so let's take this 6 out, right? Let's take this 6 out. 6 is the height. What's the width? Width is this minus this, right? The index of 2 minus index of 5, which is 1, 6. Okay, so let's write this down here. 6. What else? Now 6 is gone. What is the next one? Next one is 5. Again, 2 is less than 5 as well, right? Which means we have also found the boundary of the rectangle with height 5. Is that correct? Right. What's going to be the area? 5 times this. Index of 2 minus this. Alright, so we have found this one. Let's write this here. Now, what's the next one? Let's move this back. What's the next one? 1. Well, sadly, 2 is greater than 1. So we have not yet found the right boundary of the rectangle with height 1. It's still not found. We can just put 2 here. And then we go to the next element, which is 3. Same case. 3 is greater than 2. We have not yet found the right boundaries. Let's write down the 3 here. Okay, so we are through the array, but we still have 3 elements remaining for which we have not yet figured out the area. Okay, and one of these could be the largest area. Let's try to figure this out. Now, since we know that we have reached towards the end of this element and we have not yet found the right boundary, it means the right boundary is the end of the array itself. Okay, and what's the left boundary for each of these? We know the left boundary is just the element towards the left of it. Now we can figure out the area. Let's take out this 3. 3 times, what's going to be the width? Width is going to be just this minus this, which is the index of 2, equal to 3. Right. Just write down 3 here. Next, We've done with this 3. Let's take out this 2. What's the 2? It's going to be the length of the array. And then what's towards the left? This point. 8. Okay, so we have found this area too. And then we want one more, which is the last one. 1. So 1 times, what's the right? It is 6. Left is 0. 6. So we have found the area corresponding to each of these heights. Let's write these down again. What are the areas? 2, 6, 10, 6, 8, and 3. Now you can go ahead to the histogram and check this viewing diagram. And the largest of these is going to be our answer, which is in fact our original solution. Now, what are the points to note about this process that we did? There are in fact 3 points to note. The first point is, if you look at our list, we are only ever inserting elements from one side and then considering them or removing them from the same side. So if we were to just rotate this list by 90 degrees, we'll see that this is in fact a stack. So we're going to be using the stack data structure to store those elements for which we have not yet found the right boundary. The second thing, our stack is in fact storing elements in an order such that the left boundary of the rectangle with the height is the element below our corresponding height. What that means is that our stack is going to have non-decreasing elements. This is also enforced by the fact that whenever you see an element which is smaller than the top of the stack, then that means you have found the right boundary. Which means go ahead and calculate the area. Alright, so that gives us an intuition of the solution. And now we're going to go to LeetCode and implement. Let's start writing some code now. Here we are at LeetCode and we're going to try to implement the algorithm which we just went through in Python. But before we get to that, remember that our solution required a stack data structure. Well, the Python list provides a very good alternative to a stack. But for those of you out there who are not using Python, I'm going to implement a stack class here just in case. Okay, now this stack class provides you all the usual functions such as push, pop, peek, and is empty. Feel free to go through the code, and if you have any questions, just put them in the comment box. But we're going to move on to the solution of the original problem that we had. So the first thing we're going to do is create an instance of the stack. And then we're going to create another variable, max size equal to 0, which is going to be the size of the largest rectangle. Okay, remember that we had to calculate the max of all the rectangles. Well, this is going to keep track of that while we go through the array. Okay, let's start our for loop now. And we're going to use the enumerate function on the heights array so that we can get the index of every value in the list. Then we move on to the stack and see if it is empty or not. If it has something, then there's a possibility that there might be an element in there for which we have found the right boundary of the rectangle. Okay, but first of all, let's take a peek at what is there at top of the stack. And since our stack stores both the index as well as the value, we're going to do a stack.peek and get both the values. And then in case the current element in the array is the right boundary, what will be the end index? It will be I minus 1. Okay, now we're going to check if it can serve as the right boundary or not. What is that? If v2 is greater than v. This is the condition. then we can just remove the top of the element of the stack because we will calculate its area and we do not need it anymore. Now remember that we do not need to store these values because these are already stored in I2 and V2 through a peek call. Okay. Then starting index could be 0, which is the left boundary of the current element at the top of the stack. But it could also be non-zero, in which case, if the stack is not empty, which means there's an element below the top, and what is it going to be? Then the starting index is going to be whatever is at the top, its index and plus 1. Okay. Now we need to calculate the area given these parameters. The area would be end index, which is the right boundary, minus starting index, which is the left boundary, plus 1 times the height. What is the height of the element at the top of the stack? Well, it's going to be just the value, which is times v2. This is the area. But remember that we want to store the largest area in our max size variable. So what could we do? We can just do this. We can assign this to the max of max size and this area, new area that we calculated. Okay, but now we need to keep doing this up until we can find a value such that this v2 is greater than v. Well, in order to do that, we can simply replace this if with a while, but we have to make sure that we are not doing this for an empty stack. And how can we take care of that? Well, it's fairly simple. We just have to say that if stack is empty, then we can break the loop. But we have to take care of one more thing. If the stack is not empty, then we have to update the values of I2 and V2 with the element at the top of the stack. Okay, now that that is done and we are through the stack, we have to push our new array element into the stack as well. It's going to be stack of push. We're going to push a tuple here. Okay, now we have traversed the entire array. But remember that there might still be certain elements in the stack. It might not be empty. So we have to calculate the areas for those values as well. So while not stack, well, we're going to do the same thing that we did up there. But instead of doing a peek, we can simply do a pop. Why? Because the right boundary is already determined now. What is it? This is the length of our array. -1 for adjustments. And then the start index is going to be 0 again, and with the same condition as before, if the stack is not empty, then we could update this to whatever was below the element. Okay, and then the same thing for calculation of the area, which is max of max size comma ei minus si plus 1 times height, which is v. Now we have emptied the stack as well, and whatever is the value stored in the max size is going to be our result. Now let's try to see if this runs or not. Okay, it's accepted. Now let's submit our solution. Okay, great. Looks like we've solved the problem. Okay, please feel free to go through the video again, and if you have any questions, put in the comments and I'll reply. Alright, thank you for watching the video. Please like and subscribe my channel, and have a good day everyone.